So we're going to look at another problem with an ICE table. So you're given hydrogen gas plus carbon dioxide gas produces steam plus carbon monoxide gas at 700 degrees Celsius. The K, which is the KEQ, is 0.534. You're asked to calculate the number of moles of hydrogen gas that are present in equilibrium if a mixture of 0.300 moles of carbon monoxide and 0.300 moles of steam is heated to 700 degrees C in a 10-liter container. So we would first want to calculate the molarity of the steam. So that's how we get this. And the molarity of the carbon monoxide. So that's how we get this. Now notice that in this case, we are given the products and we have 0 of the reactants. So we're starting with products and the reaction will go this way. So we have, starting for our initial, we have that filled in, and then remember you're losing the product. So that's why we have a minus X, a minus X. There's one of these, that's why it's minus 1X. One of these, so minus 1X. We're gaining on this side, so plus X and plus X. So now we just follow our directions. 0 plus X gives us X. 0 plus X gives us X. 0.0300 minus X. And 0.300 minus X. We set up our K expression, products over reactants. In this case, everything's 1 to 1 to 1 to 1. And then we put our value in for K. We put in our equilibrium for the steam, our equilibrium for the carbon monoxide, and then the hydrogen gas was X, and the carbon dioxide gas was X. So in this particular case, we take the square root of both sides to simplify. So we would have the square root of the 0.545, and then if we take the square root of this, we get this. We solve for X, that is our molarity of hydrogen gas. We multiply it by our liters. Liters cancel, and we get moles. Okay, let's try another problem. So in this particular case, we are given our carbon monoxide, and we're given moles of hydrogen gas, a 10-liter vessel. And we're told that initially we have 0.387 moles of steam. We're going to convert our moles of carbon monoxide to molarity and our moles of hydrogen gas to molarity. Now in this case, we're starting with reactants and we're making products. So we'd be going this way. That's why we're starting with 0 methane and 0 water. You were given the carbon monoxide, hydrogen gas, water. You had to determine on your own that it was methane. So now we have our initial. We're going to subtract x, subtract 3x because of this 3. We're gaining, so we add plus x. So now we have our directions. So 0.100 minus x, 0.3000 minus 3x, x, and x. So let's look at the moles of steam. That's at equilibrium. So they told us there's this many moles of steam specifically at equilibrium. So our concentration of steam is 0.387 moles over 10 liters. That gives us our molarity, and that's our x. So now we have our x. Now we just have to use our equilibrium row to solve for everything else. So the carbon monoxide, we're going to take the 0.100 minus x. This is our x. That gives us 0.0613 molar. And then we need to multiply by the liters because the question is asking for moles. The hydrogen, we have 0.3000 minus 3x. So we just follow our instructions. We get the molarity of the hydrogen. And again, we need to multiply by liters because the question is asking us how many moles. And then the methane is x. So we just put our x in. We want to cancel out the liters, and then we get the moles. So this question is different from the prior question. So you're going to want to practice because all the ICE table questions are going to be different. The more you practice, the better off you're going to be. So practice, practice, practice.